Okay guys, in this video, what I'm going to do, let me get set up here. It's me on camera. Oh, I don't have my document camera set up. Give me a second, guys. But just listen to me very carefully. What I'm going to do for this particular video is I'm going to go over the October 8th, October 9th, and 10th. Oh, I'm sorry, it's October 7th, October 8th, and October 9th. These were from the week 9 packet. My plan is to just do the exemplars just in person so you can see what solutions you should get. Now, there were some that we skipped. I'm going to work those out and then you'll see them again in class. Okay, so let me close this down again and open it back up. And there we go. You should see my screen in a second. Okay, so again, just so we're clear, is I'm going to go through all of the October, I don't think I have October 7th, so let me see if I have that. But I do, I'm going to start on October, let me see if I have October 7th. Yes, I do. Here we go. So I'm going to go through the packet for week 9. I'm going to work out every single problem. And the good thing that I want you to know is when I put a star by the problem, this is something that's going to help you with the interim assessment. Okay, so again, this video is going to go over the week 9 material, which we got into unit number 3. But there are in our do nows, right? There's old topics that you may see on the interim assessment. Okay, and just kind of bear with me in this video. I'm going to move pretty quick. Remember that you can pause me if you need to. All right, so here we go. I have a lot of stuff over here. Okay, so as you can see, the whole point for October the 7th, try to get this straightened up here, is we were to talk about rate of change, which was slope. Remember that we said slope is like an address, right? And when I say an address, okay, it's basically how we move. I'm going to put how we move from one point to another, okay, on a linear line. Can everybody see that? Again, how we move from one point to another on a line. Okay, that's how I am talking about address, and you're going to see that as I do problems for slope. Okay, so again, slope is the same as rate of change. And again, it's like an address. It's our rise over run. So let me put that in another color. Right here above this address, I'm going to put rise over run. Okay, you're going to see me do that quite a bit. So if you have that, and you have the paper, write this down or get a sheet of paper and write rate of change, open parentheses, close parentheses, put the word slope, and then just say an address, how we move from one point to another on a line. Okay, rise over run. Put it in your notes, use a sheet of paper. All right, so again, this is TEK number A3B. This is what the state says that I have to be able to teach you, which is to calculate the rate of change of a linear function represented in different ways. So calculate the rate of change when you're given a table, which is tabular, from a graph, get the rate of change, or algebraically, and then there may be real life or real world problems, okay? So stars will be able to find and interpret the rate of change or slope given points on a table or a graph, okay? All right, so that's the objective. Keep that straight. Maybe even write the objective down if you don't have this sheet. Very important that you know what it is you're asked to do, and then you're able to execute that, right? So calculating the rate of change from a table and a graph. Okay, so as you can see, this one is an old skill for, this is evaluating functions. So let's put evaluating functions. This was back from unit 2. So remember when we have something that says like, you know, f of x, but in this case it's h of b. Here is the actual function that they gave you, and they want to know what would be the value of this when b is equal to -3. Okay, so since b equals -3, b is -3. we're going to take that -3 and we're going to plug it into the parentheses. So you should write H, open parentheses, I'm putting in -3 because that's my B value. Remember, this is your input. This is our input, which is our independent variable. And I'm going to circle in another color. All of this, the value that we get out, this is our output. Okay, this is our output. Okay, H of B. But we're basically looking at the H function at -3. So what do? We're going to substitute in -3 where these B's are. Substitute. So I'm going to do 3, open parentheses, and watch me plug in -3 for B here. Close it. I'll square. And then I'm going to do -2, open parentheses. Let me zoom in. -3 for B here. Close it. And then +1. Okay, so I hope we can see that. Okay, so basically we'll keep the same notation for this function. What will happen when B is -3 into the H function? What do we get out? Okay, so I'm going to grab my calculator, and remember, when we do computation or evaluating, we do our what? We do parentheses and exponents. So I'm going to put a 3, open parentheses, and I'm doing -3 squared. So in my calculator, I'm going to do an open parentheses, -3, close, raised to the second power, enter, that's +9, okay? So I got 3 times 9. Okay, then what I'm going to look at is, hey, I have -2, make sure you put the sign with this number, -2 times -3, a negative times a negative is a positive, and then 2 times 3 is 6, so this is a +6, +1. Very simple, okay? Notice how I'm going to do my math again from left to right. I go back to the left, I drop this down because I'm evaluating the function at -3, and now I'm just going to type this into my calculator, right? So I'm going to clear this out, and I'm going to do 3 times 9, and then I had what? +6, +1, so 34. That's it. So the answer is 34. And remember that I told you that because that -3 is the input, because I plugged it into the function, and as you can see, when I plugged it into that H function, I got out the output is 34. So this is my Y value, everybody, and this is my X value. And I know in this case they called it B as in boy, but traditionally, whatever's in the parentheses is the X. When you evaluate and you get the answer, once you plug it into the function, that's your Y. So basically I can produce the point, -3, 34. Okay, so I hope that makes sense. Don't miss it. Take your time. Be careful with your substitution. Okay, now here's another problem. This will help you with the interim assessment that had to do with Unit 1, which was about equations. So when I read this, it says, solve each equation. Which one leaves a true or all real numbers solution? So I'm going to tell myself, hey, this has to do with equations. Also, since they're talking about true statements and all real numbers, this was the one about special solutions. So I know that some of you have already completed this, but again, just rework these again or just add these notes in as you're watching the video. So here we go. So when I look at the first one, again, this is equations, special solutions. So when I look at this, look what I have. I have 3y plus 3, 3y minus 3. Now real quick, I'm going to grab a sheet of paper and write that down. So 3y plus 3 does that equal 3y minus 3? Well, here's the deal. Ready? If I'm going to go ahead and solve this, right, I would do what? Letters to the left, okay, and then numbers to the right. So let's just check this out for a second. So I'm going to move this 3y over to this side. Well, when I move a term from one side to the other, I change the sign. So I'm going to subtract 3y, and look what happens. Remember, special solutions, the variable goes away. So this is 0, this is 0, and now I'm going to drop down those two constants and see if I get a true or false statement. So 3 equals -3, and you and I know that is not true, so therefore this problem is no solution. Okay, no solution. So this is not all real numbers. This is not a true statement. Remember to write, this is a false statement. Okay, so that means I'm going to cancel out the first option. Everybody got that down? All right, here we go. So this one is not an identity. It does not make a true solution. Now let's look at this one. For the next one, we have 5w plus 8. I think it was minus w equals, I'll be toggling back and forth. Yep, equals 6w minus 2w minus 4. Okay, so again, we're solving. So the first thing when I look, again, we do math from left over to right. Same thing with the periodic table. Everything in the US is left to right, okay? So I come over here, and one thing I notice is I say, hey, I have 5w plus 8 minus w. Well, my like terms, because there's no distributive property, is this 5w and that negative w. So I'm going to combine those because that's combining like terms. And I'm going to get 5w minus 1w, if you want to see the 1. That's where I get 4w from. So this is 4w plus 8 equals. So I'm done with this side. There's nothing else to do because, again, these are unlike terms. This one has a variable. This one is a constant. So now I come over here and I say, hey, look, parentheses, there's a number in the front. It's a negative 2. I got to do the distributive property. Okay, so leave the 6w alone. And I'm going to get negative 2 times w is negative 2w. Negative 2 times negative 4 is positive 8. Okay, so now I drop down these terms again because there's nothing to do on the left. And then this is 4w when you do your subtraction. And then, wow, look, it's looking like an identity because this side looks just like this side. It's identical, right? So again, just to prove it to you, I'm going to subtract 4w from both sides. That's 0. That's 0. See, 8 equals 8. This is true. So this is all real numbers or infinite solution. So all real numbers, infinite solutions. And what that means, guys, is that if we go back to our original problem, okay, and I say, hey, let w equal 2. If I plug in 2 here and there and there and there, everywhere w is, I'm going to get 2 equal numbers on both sides. Then I can turn around, and I plug in negative 3 for w. Everywhere is going to be equal. So when I say all real numbers are infinite solutions, that means w can be anything. It does not matter what value of w I choose. It's going to make this become a true statement. Okay, I hope that makes sense. Whereas the last one, there is no number of y that I could plug in on this side or this side. It will never be equal. All right, let's go to the next one. So far we like B. Now let's go to C. And the good thing about this problem, everybody, is that this is helping you to review solving equations. So I hope you're doing this, all right? So we got 14 minus, open parentheses, 4v plus 4 equal, I think I wrote it down right. Okay, let me check. Yep, okay. All right, so this one, watch very carefully. We always start on the left. I'm going to drop the 14 down because there's nothing to do. He's just sitting in the front. Where that negative is, that's a negative 1. So I have to do the distributive property. So negative 1 times 4v is negative 4v. Negative 1 times 4 is negative 4. Put my equal sign. And then there's nothing to do on this side, so I'm going to drop these two terms down because they're unlike terms. So negative 4v minus 10. All right, so I'm going to go back over to the left and say, hey, do I have any distributive property? I don't, because I already took care of it. Do I have any CLT, combined like terms? And I do. I have this positive 14 and this negative 4. Okay, so now when we sit back and look at this, I know that 14 minus 4 is 10 minus 4v. That's on the left side. Can't do anything else. And then I have negative 4v minus 10. Now look at this very carefully, okay? And again, I'm going to focus on the v's for a second. So I'm going to cover the 10s up. You see how you have a negative 4v and a negative 4v? So far that looks pretty good. Now the problem becomes this part. Look over here on the right. There's a negative 10, and guess what, guys? That's a positive 10. Okay, so now for the sake of doing this, I'm going to move this over to this side, to the left. So I'm going to add 4v. Add 4v, this is 0, and this is 0. Okay, so now we drop our numbers down and look what we get. We get, does 10 positive equal negative 10? No, that is not true. This is false. So this one again is no solution. There is no value of v that I can plug into the original equation to make these both sides equal. So we do not like the third option. Okay, so again, I'm just showing you back to solving, but again, these are special solutions. The variable will go away. So we don't like C. Last one. Okay, I'll work this one on the page. Okay, so I have 3m minus 6 equals 4m plus 7 minus m. Well, I can't do anything on this side because they're unlike terms. So let's just drop them down. 4m minus 1m, that's a 3m, plus 7. So look, we got the same number of m's on both sides, but again, move it to the left. So change the sign, inverse operation. Negative 6, does that equal positive 7? No, it does not. So this is a false statement. So D is also no solution, and so we do not want this answer. The answer was B. So if they ask you this on the star, whether they give you a problem like this, you should be able by function notation to understand that, hey, B is equal to this number. I have to plug it in carefully, use my parentheses, use the calculator. There's the answer, 34. For this one, you have to understand that a true statement means all real numbers or infinite solutions. So you have to work out all of these problems very carefully and figure out which one gives you like the number equals the same number. Okay, so I hope that was a review. This one was from Unit 2, this was from Unit 1. Okay, so now let's get into the actual objective one more time. Here is rate of change. So we are to do what? To calculate the rate of change or the slope from a table or a graph. Okay, so here we go. So now in this one, I put some formulas up at the top. Let's read our key points. So the first key point is to carefully look at our x coordinates, take the difference of each domain value, your two different x values, carefully look at your y coordinates, take the difference and subtract the two different y values from the table, and calculate the slope on the graph or the table, rise over run. Here's the formula. Okay, so please, I cannot stress to you enough. They love to put slope problems on the star. Okay, so it's y2 minus y1 over x2 minus x1. Remember, I told you this is like an address. Moving one point to another on a line. It's how we move up or down, and then left or right. Okay, now you cannot see that, that's pretty small, but I'm going to zoom in just to show you. So basically, we end up having, give it a second, see, there'll be a point 1, which is the first point on the line or the table. That's your x1, y1. Point number 2 is x2, y2. So if you look at this table here, what I'm saying is that this one right here is our first point. So what does that make? That makes negative 2, comma, positive 12. Whoops, positive 12. So what is this? This is my x1, comma, this is my y1, because that's point 1. Okay. Now I'm going to go to this point here, and I'm going to do it again. This is point number 2, x2, y2. So I make my coordinate point 0, comma 3. And again, this is the x2 is the 0, y2 is the 3. All right, so very carefully, now that I have my x1, y1, x2, y2, we're going to plug it into this formula and calculate slope. So here we go. I'm going to zoom out. Okay, so I'm going to start off by writing my formula on the side. M is the slope. It's y2 minus y1 divided by x2 minus x1. Now, if you want me to do this, I will do it for you guys. So let's list these out just in case, right? So x1 is equal to negative 2, y1 is equal to 12, x2 is equal to 0, y2 is equal to positive 3. So again, I'm going to plug those numbers in to this formula. So now I have m is equal to, y2 is 3, put your subtraction symbol, minus y. Okay, and so we did our subtraction for the numerator. Now let's do our division bar. x2 is 0. Put your minus. x1, be careful with that when there's a negative, right? So you have to put subtract, and then x1 is negative 2, so minus 2. Okay, remember, as soon as you put everything in, as soon as you see that double negative, change it to a plus. All right, so here we go. M is equal to, now if you want to, again, I know my integer rules. I know some of us know them just like that. So I know to change that to a plus, bump back the negative. So at the top, I have a negative 9 over 2. That's the slope. But if you want to use the calculator, after you write your formula down and you're very careful with your substitution, it's just 3 minus 12. There's the negative 9. And then, of course, everybody should know very carefully, 0 plus 2 is 2. Okay, so the answer is that our slope is negative 9 over 2. And so the answer choice here was B. Okay, that's simple. You will get a problem like this. Why would we miss it? Okay, guys, so again, be very careful. You will have a formula sheet on the star. So there's the formula y2 minus y1 over x2 minus x1. I had you do a homework over this, so you should have this formula memorized. If you don't, get it memorized, okay? So that's a table. Let's talk about a graph now. Okay, so here's a graph they give us, and it says find the slope given the 2 points on the graph. So the first thing, they already kind of put some solid points there, okay? So I'm going to circle this one, and I'm going to tell myself, hey, this is the origin, which is 0, 0, and I want to go to this point. So I would go down. This is negative 1, negative 2, negative 3. So this point right here is 0, comma, negative 3, because I went nowhere left or right. I just went down 3 on the y-axis, okay? Now I want to go back to 0, 0 and go to this point, and this point is, there's 0, there's 1, and there's 2. So this one, because I went to the right 2, in the x direction, this is 2, comma, 0. Because again, I went to the right 2, but I did not go up or down. I stayed on the x-axis. This one I stayed on the y-axis, so there's a y value. So here are my 2 points. Ready? 2, comma, 0, 0, comma, negative 3. So very carefully, I begin to label that this is the x1, y1. Here is your x2, y2, because remember, when we have coordinates, it goes x first, which means we go where? Either to the left or to the right first. Then we go y, which means we either go up or down, depending on the value, okay? If I go up, it was a positive y. If I go down, it was a negative y. If I go to the left, it was a negative x. If I go to the right, it was a positive x. So let me just label that. This is a positive y, and down is a negative y. Hope that makes sense. Okay, so now we go back up at the top and get our formula. y2 minus y1 over x2 minus x1. So now I go here and I write my formula down. I do the same steps, you guys, every time. That's why it's good to practice and do homework. All right, so very carefully. What is y2? Well, y2 is equal to negative 3. So I'm going to put my equal sign, and right where that y2 is, I'm going to put a negative 3. Put my subtraction symbol. What is my y1? 0. Divided by, that's a division bar. And then what is my x2? 0. Subtraction. What is my x1? 2. Okay, so again, any number minus 0 is just itself. So up here is negative 3 over, and then 0 minus 2, or change that to a plus, bump back the negative. This is negative 2. And then we know a negative divided by a negative is a positive. So the answer is M equals 3 over 2. So now let's talk about that address, okay? So this up here is my rise, which means I need to go what? This is a positive 3, so we're going to go up 3. So I'm going to tell myself 3 up over. The bottom number is x, so the change in the y. The bottom number is the run, which is the change in the x, because when we run left or right. Because it's positive, we're going to go 2 to the right. And there's the address, okay? Also, something I have not talked about, which I definitely need to do on Monday, is that when you have a positive M, your line looks like this. It's going to go up to the right, a positive slope. It's going to increase, right? But let's talk about the address. The address is to go what? 3 up and 2 to the right. So if I go to this bottom point, the furthest to the left, how do I get from here to here? What's the address? Well, I go up 3. So look at the red line. I go up 1, 2, 3, up. So that's 3 up. And then I go 1, 2 to the right. I don't know if y'all can see that, to right. So that's the address, you see? From there to get to here, I go up 3 to the 2, right to the 2. And I can do it again very carefully if you can look. If I go 1, 2, 3 up, and then 1, 2 to the right, you see I would touch the line again and be at this point right here. So that's what slope does. Slope gives you the relationship between your points and how to get to them. So I hope that makes sense now. Okay, so now let's go to the next one. So those were our 2 model questions. Let's go now to 2 guided questions. So same thing for this one. Determine the rate of change. As soon as I see that on a test, I say, oh, you want slope. So I'll rewrite the word slope. Determine the rate of change. Determine the slope, okay, given the table for this linear function. So again, this one is my x1. This is y1. Here's the x2. There's the y2. And again, and I'll show it to you super fast. What if I use these 2 points? So I'm going to use those 2, and those 2, you'll get the same answer. So let's put our formula. M is equal to y2 minus y1 over x2 minus x1. You guys are going to be super, super masters of slope when this is all said and over with, if we're practicing, okay? And we're taking it to really practice. So my y2 is the 60 minus y1 is the 40 divided by x2 is negative 15 minus negative 20. Be careful with those negatives and positives. First thing I do, I see minus minus, change it to plus plus. So 60 minus 40 is 20 divided by, and then here, this is a negative and a positive, so I'm going to subtract, keep the sign of the bigger number. So this is a positive 5. And the final answer is m is equal to 4. 20 divided by 5 is 4. Okay, so I guess, let me see where I can write it right here. M equals 4. That's the slope. What is the address? The address, if I put this over 1, is to go 4 up, 1 to the right. Okay? All right, so now I'm going to do it again, but now I'm going to use these 2 points. Let's see if we get the same answer. Because remember, all of these guys are on the line, so it should be the same address. So let me call this one my x1. This is my y1. Here's my x2. Here's y2. So again, m equals y2 is 100 minus, y2 minus y1 is 80 divided by negative 5 minus 10. Remember that there's a subtraction symbol in the formula. Okay, so here's what we got. Ready? M is equal to 100 minus 80 is again 20 divided by 10 minus 5 is 5. And what do you know? Same address. 4 up, 1 to the right. It should always be the same. And if I use these 2 points in the middle, I'll get the same answer. That's the address. All right, now let's look at a graph. Same thing. Now this one, what we'll do is we can pull 2 points, right? We did this one in class. We said, hey, this is 1, 150. And we could pull this point off of here. And again, I went to x equal 3. Then I went up and it's 350. Okay, so 3, 350. Okay, and then I could just do the calculation, right? So real fast, remember, this is the x, this is the y. This is the x, this is the y. So I'm going to call this one my 0.1 and this one's 0.2. So this is x1, y1, x2, y2. So real fast, I'll plug it in. M is equal to y2 is 350 minus 150 for our y1. And then x2 is 3 minus 1, which is 2. So the answer here would be 2 on the bottom, and $350 minus $150 is going to be 200. And then 200 divided by 2 is 100. So there's $100 every single deposit that we put in every deposit, we're putting $100 in. And so this is like a real world application of a savings account. So $100 deposit for every one, I guess we'll say, yeah, one deposit. So every deposit we do, we're putting in $100. Okay, now, what if, for the sake of time, the answer was A? Okay, $100 per deposit. What if you want to do this faster? Okay, so let me show you how we do this. So I want to go from this point to this point, right? So I say, oh, how do I get there if I go up, right? Well, I go 2 up. So if I go up 1, 2, up, and then to touch the line, I go over 1. So look what this is telling me. This is telling me that I'm going, as I don't have enough room, but this is going 2 up. I'll just write on the side, 2 up, 1 to the right. But every time that I jump, you guys, it's $50. You see how it went from 50 to 100? So one jump is 50 and another jump is 50. And so 50 plus 50, right? Those 2 jumps, that's 100 right there. And then when I go to the right one, that's 1 deposit. So you see how you get the same thing? It's $100 per 1 deposit. Let me show you again. I want to go from this point to this point. Same thing. I go up $50. I go up another 50. 50 plus 50 is 100. And then I go over 1. Same thing again. Up 2, over 1. Those 2 jumps are 50 each, 100. Easy, easy. So you can do it right off of a graph or use the formula. Okay, let's do our independent practice. All right. Again, I put the formula there. Calculate the rate of change. And again, very simple. 2 points. So I start here at, this is always 0, 0, right? Smack in the middle. This is 0, 0. So to go here, I'm going to go left or right first. So I notice, hey, the point is over this side. Wait, so I'm going to go how many jumps? Just 1 to the right. And I'm coming down. 1, 2, 3, 4. So this point is 1, negative 4. 1, negative 4. This point right here, go back to 0, 0. How do I get over there? Well, I go to the right. 1, 2, 3, 4 jumps to the right. And then I go up 1, 2, 3. So this one is 4, 3. And then I write it nice and big over here. 4, 3. Then I label at the top, hey, your x1, your y1, because that's point 1, x2, y2. Write my formula down. It's up at the top. So again, y2 is 3 minus y1 is negative 4 over x2, put it down here at the bottom. So right here, I'm going to put a 4 minus, and then x1, which is right there, I'm putting a 1. So just want to be clear. Keep that formula right there so you can see it. Now calculate, and it's 7 over 3 is the slope. So what does that mean as an address? We're going 7 up, 3 to the right. That is the address to move to every single point on this line. So let's check it. Ready? I want to go from here to here. The other thing cool is, isn't this a positive number? M is a positive. And remember, like I said, if M is equal to a positive number, okay, that means it's going to look up and increasing like that. If M is a negative number, negative, the slope is going to go down to the right. So when it looks like that, it has a negative slope. It's decreasing. If it looks like this, it has a positive slope. It's increasing. Okay, so let's check the address. Ready? 7 up. So I go here, 1, 2, 3, 4, 5, 6, 7 jumps up, 3 to the right. 1, 2, 3, I touch the line. So I can't stress to you enough, it's the address or the change in the y over the change in the x. It's how I get from there to there if I was going in those 2 pieces, rise over run. All right, here's the next one. This one. And I think a lot of people have a hard time, but again, guys, this is the middle, okay? So here's your 0, 0, start here. And I want to go to there, so that is 1, 2, 3, 4 jumps to the left. So this is negative 4, 0. And then I go back to 0, 0, and I want to get to this point. So I go to the left again, 1, 2 to the left, and then 1, 2, 3 down. So that's negative 2, negative 3. Take your time with that, okay? And I'm just going to jump right in. y2 is -3. It's always the one on the right, far right is our y2, minus 0, the one on the right in this point, over x2 minus -4. Plus. Here we go. So -3 minus 0 is just itself. So I have -3 over, and then subtract these two. So 4 minus 2 is 2. So there's the address. The address is to go what? 3 down. 3 down because of the negative. That's our rise. But we ended up going down because of the negative. Over, and then 2 to the right because this is positive. So we're going to go 2 right for our run. All right, so let's see if that's true. Do we go 3 down and 2 to the right to touch the line from point to point? Sure we do. From this point going over to this one, I'm going to go 3 down, 1, 2, 3, down, and then I go over 1, 2. And if I did it again, and we'll go off the paper, but if I went, look, 1, 2, maybe a nice fair jump, 3, and then I went over 1, boom, 2, see? It would go through there. Well, actually, wait. It would go 1 right here, 2. It would go through there. So it would be the same. Down 3, over 2. All right, I hope that makes sense. And of course, you know, we did this one, so that's fine. So I hope this is making a lot of sense to everybody. It was slope, and I know there's a video on slope. But the biggest thing I want you to see one more time, I am going to do one with points super fast, is you have to be able to get the points off of a graph, and sometimes they just give them to you. Okay, so let's do this one because there's bigger numbers, and I'll just stop the video there for October 7th. Okay, so, and then we'll do a real world problem, and then I'll stop it. Here we go. So for this one, I'm going to label that this one is my x1. The 7 is my y1. This one's x2, comma, this one's y2. So the formula says m is equal to y2 minus y1 over x2 minus x1. y2 is 12 minus 7 divided by -39, which is our x2, minus 26. Okay. Now this one I'm just going to use the calculator just because, you know, those of you that the calculator is your only friend, just playing. There's 5 in the numerator. 12 minus 7 is 5 over. This is a -39 minus 26, so I'm going to hit the negative button. -39 minus, see, -39 minus 26, -65. And where'd they get that from? Change to a plus. Bump back the negative. If there's 2 negatives, add and keep it negative. -65. And I think this is the part that really gets everybody, is reducing the fraction. So of course, you know, 5 goes into both of those, right? So if I divide this one by 5, I get a 1 over. If I divide the bottom one by 5, 65 divided by 5, -13. And let's be clear about this, okay, guys? You can put the negative in the numerator. So I don't care if you put the answer as 1 over -13 or m is equal to -1 over +13. This is the same answer. What's the address? The address is to go 1 down and 13 to the right. Or in this case, 1 up, 13 to the left. It's the same place. Don't worry about that. Same place. But of course, if it's multiple choice, we love it. A. And because it's negative, what would the line actually look like? If you were to plot this point and then plot this point, basically your line would be going down, down to the right because it has a negative m. Okay? So again, pretty easy, same thing. All right, so let's look at this one. That's a real world problem. Again, we talked about finding nice, good, clean points the best way that we can. This one looks like a good point right here, which was 1, 10. Notice that it says, again, we have this Earth's atmosphere and the altitude above sea level, and then that word, which of these best represents the rate of change for the temperature and this altitude, right? So you may not get a perfect answer, but you're getting really close to it, and so we have to make the best answer choice. So I see this is 1, 10. Let me zoom in. Okay, and another really good one, because you guys were really awesome in class and people found some great points. I mean, this one just jumps out to me right here. 7, negative 30. 7 for the x, negative 30 for the y, and that was the y-axis. So, comma, negative 30. Okay. Another one I think someone called out was this one, 4, negative 10. Okay, but again, this one is the one that jumped out to me, and that one. So let's write those down super quick. So if we have 1, 10, 7, negative 30, I'm going to label this one as x1, y1, x2, y2. Sorry, I was off the page. Okay, and here's the formula. M is equal to y2, negative 30, minus y1 is 10, divided by 7 minus 1. So this is negative 40, because I changed to a plus, bump back the negative, atom, negative 40 over 6. So then I get my calculator because I don't see that as an answer choice. My answer choice is in decimals. So I'm going to do negative 40 divided by 6, hit enter. And if you can see that, see, negative 6.66667, right? So the closest thing to that, so I write it down, m is equal to negative 6.667. The closest thing to that is A, which is F, I'm sorry. That's it. All right, so this concludes this video. I hope that you feel a lot more comfortable with slope, rate of change. Super important, because I cannot stress to you enough, you are going to see it on the star. All right, so that concludes this video, and I did quite a few problems from this one.